What happened after Starship Flight Test 12 was fascinating. Depending on where you looked online, people saw two completely different realities. On one side, SpaceX fans calling it another huge success. Version 3 Starship performed incredibly well. The ship successfully reached space on a suborbital trajectory, deployed its payloads and performed a controlled re-entry into the Indian Ocean. Major milestones were achieved. And yes, there were issues. Two Raptor engines shut down and the booster had a hard splashdown. But for many people this was still engineering process. Now on the other side, I saw headlines, comments and social media posts calling it environmental destruction, space pollution, rich billionaires destroying the oceans. Some people asked, we are told to recycle plastic and separate garbage, so why are rockets allowed to explode in the ocean? And honestly, this is a fair question, so let's actually look at the facts. First, SpaceX does not want Starship to end in the ocean forever. These ocean splashdowns are temporary test procedures. Most likely only a few more Starship test flights will end this way. After that, the plan is to catch Starship itself with the Mechazilla tower, just like the Super Heavy booster. Meaning, in the future, both stages are intended to return to Starbase instead of ending up in the ocean. That changes the environmental equation dramatically. Now let's talk about the rocket fuel itself. Starship uses liquid methane and liquid oxygen. And surprisingly, that is already cleaner than many traditional rocket systems. Older rockets often use kerosene-based fuel or even more problematic propellants. Kerosene produces soot and black carbon. Methane burns cleaner. Still, not emission-free, but cleaner. A single Starship launch produces roughly around 2,500 to 3,500 tons of CO₂. Now that sounds massive, but in perspective, that is roughly equal to around a dozen full transatlantic airliner flights. And across the North Atlantic alone, there are already more than 1,000 flights every single day between Europe and North America. So yes, one Starship launch is big, but compared to global aviation, shipping, heavy industry or coal power plants, spaceflight today is still tiny. Commercial aviation alone produces around 2.5% of global CO₂ emissions. Spaceflight today is only a small fraction of that. Now, what about the Starship explosion in the Indian Ocean? Did it pollute the ocean? Yes. Technically, of course it did. There were debris, metal fragments and leftover materials entering the ocean. SpaceX has recovered Starship hardware from the ocean before and has repeatedly used recovered components to improve future vehicles. However, there is currently no public confirmation that all debris from Flight 12 will be recovered. In reality, some larger components may be retrieved for engineering analysis, while much of the remaining structure will likely stay on the ocean floor. The important point is that these splashdowns are temporary test procedures. SpaceX ultimately wants both the Super Heavy booster and Starship itself to return to Starbase and be caught by the Mechazilla tower, eliminating that need for planned ocean splashdowns altogether. Again, that does not mean it is harmless, but scale matters. Every year, millions of tons of plastic waste enter the aquatic ecosystem. That means tens of thousands of tons per day. Compared to that, the debris from one Starship splashdown is extremely small, likely far below 1% of the plastic pollution entering aquatic ecosystems on a single day. That does not excuse it, but it puts it into perspective. And Starship is not the only rocket facing these questions. Blue Origin's New Glenn rocket exploded during a static fire test at Cape Canaveral. A huge fireball, a dramatic failure, a major setback for Jeff Bezos' space company. And yes, that also has an environmental footprint. Fuel burned, hardware destroyed, infrastructure damaged. But again, context matters. Every day around the world, wars destroy tanks, aircraft, ships, buildings and infrastructure. Bombs, missiles and burning fuel create massive environmental damage. Compared to the ongoing environmental footprint of military conflicts, a handful of rocket failures per year are small. That does not mean rocket explosions are good. It means we should be honest about scale. If we care about the environment, we should compare visible rocket failures with the biggest sources of pollution, not just the most dramatic video clips on social media. And here is the really important part. SpaceX is actually trying to move toward greener rocket fuel. Long-term, methane could theoretically become almost carbon neutral. How? By producing synthetic methane using renewable energy, captured CO₂ and hydrogen. In other words, the CO₂ released during launch could one day equal the CO₂ previously removed from the atmosphere. Now some people ask, why don't we simply launch rockets without chemical fuel? And the answer is because escaping Earth's gravity requires an enormous amount of energy delivered almost instantly. That is the key challenge. Ion engines, nuclear electric propulsion and even future fusion concepts may work incredibly well in deep space. But they do not produce enough thrust for liftoff from Earth. Chemical rockets still provide the extreme power needed during the first minutes of launch. Hydrogen rockets are another option. They produced almost no CO₂. But hydrogen is extremely difficult to store, requires massive tanks and creates major engineering challenges. That is why many experts currently see methane as the best compromise between performance, reusability and future sustainability. And in the future, we may see hybrid systems. Chemical rockets launching from Earth, while nuclear or fusion propulsion systems take over once spacecraft reach orbit. Now there is another criticism I hear all the time. Why spend money on space when we have problems on Earth? Again, fair question, but the numbers are surprising. Humanity spends roughly $135 billion per year in government space budgets. That sounds like a huge amount of money. But globally, it represents only about 0.13% of the world's annual economic output. In other words, curiosity, discovery, and research cost us only a tiny fraction of what humanity spends every year on many other areas. And space is not just about rockets. Space gives us satellites, GPS, weather forecasting, climate monitoring, telecommunications, Earth observation, disaster warning systems, and scientific breakthroughs. The question is not only how much does space cost, the question is also what would we lose if we stopped exploring. Now, there is still a huge debate coming. Because if Elon Musk's vision becomes reality and Starship launches daily or hundreds of times per year, or if China, NASA and private companies all start building lunar infrastructure, then spaceflight emissions will absolutely become relevant. Even then, spaceflight would probably remain below today's aviation industry, but it would no longer be negligible. And this is why the next decade matters so much, because humanity is entering a new space age. And whether people like it or not, the new space economy is coming. Moon bases are coming, Mars missions are coming, orbital factories are coming. The question is no longer, will this happen? The real question is, how sustainable can we make it? And honestly, this is something I personally think about a lot, because I care about the environment. I recycle, I support environmental organizations, and of course, I drive a Tesla. And yes, I know electric cars are not perfect either. Battery production requires raw materials like lithium, nickel, and cobalt. Mining can consume water, damage ecosystems, and create social problems. But when the scientists compare the full life cycle emissions of electric cars with gasoline cars, including battery production, electric cars usually come out significantly better over their lifetime, especially in countries with cleaner electricity. So no, technology is not perfect. But maybe progress is not about achieving zero impact overnight. Maybe progress is about continuously reducing humanity's footprint while still moving civilization forward. Because at the same time, I also believe curiosity is one of humanity's greatest forces. Exploration is part of who we are. From crossing the oceans to climbing mountains to landing on the moon. And now to reaching Mars. Humanity did not become a global civilization by staying where it was. We became one by exploring what was beyond the horizon. So maybe the future is not space exploration or environmental protection. Maybe the real challenge is making both possible at the same time. And that might become one of the biggest engineering challenges of the 21st century. Now, what do you think? Is Starship the future of humanity or an environmental risk we are underestimating? Let me know in the comments. And don't forget to like, subscribe if you haven't already, and I will see you in the next episode. Ciao!